All right, so let's go ahead and get started. Topic 1.1, changes in tandem. Okay, so first one's just a couple fill in the blanks, some definitions that you should already know. A function is a mathematical relation that maps a set of input values to a set of output values. Now here's where it's not a relation and it's actually a function, okay? Such that each input value is mapped to exactly one output value. That's the 1-to-1 rule, okay? So in algebra 2, we would have talked about like a vertical line test. The thing is, sometimes a vertical line test doesn't work as far as testing whether or not something is a function. And we're going to figure out why later. So basic definition for a function, one input, one output, period. Okay, that's usually the easiest way to check it. So the set of input values is always called the domain. And we'll talk more about this as we go on. The domain is also the x, but it's very specifically the x is the independent variable. Okay, and then the set of output values is the range, and that is the dependent variable, or the y. Okay, it's going to be very, very specific in this course. There's a lot of language that you're going to learn that you are expected to use when you're taking the AP test, when you're taking my tests, and we'll talk and we'll make sure you go over always how certain things are supposed to be written. So instead of just saying the x variable or the y variable, we are very, very specific, and we say the independent and the dependent. Okay, so go ahead and go over some examples of sketching a function. All right, so specifically only from -4 to 4, so that's for your domain, since they're giving you the independent variable right there. Okay, so the function halves each input value, so it takes each of your x's, right, halves them, and then adds 1. So basically what they're asking you to graph is y equals 1/2 x plus 1. Okay, so since we're halving each of our input values and then adding 1. All right, so again, going back to algebra 1, to graph a linear function, you take the y-intercept, which is 1, right? And then the slope tells you basically where you're going to go to get your next point, next whole number point that's on the graph. So slope of 1/2 means we rise 1 and run 2. And I can go in the other direction as well. And it's still a rise 1 and a run of 2. So, and being that this is a function and it is a linear function, it is going to go forever in both directions. So we do need to make sure we put the arrows on it. Oh, wait. Nope, sorry. Cancel that, because the domain is only going from +4 to -4. My apologies. That means it actually has to stop at 4 and -4. So let me go ahead and do one more. And since the domain is specifically less than or equal to from -4 to 4, that means those dots will be closed. Okay, so if it's just a table of values, we're just going to graph some individual points. So -4, -1, -1, +2, 0, 3, 2, 3, and 4, 1. Now, I am not connecting these dots. These do not, they don't make a line of any kind that we know of so far. All we've been given is just a set of points, or basically a domain and a range value. So the only thing you can do at that point is just graph the ordered pairs that you're given. Okay, so definitely need to write this down. We're going to be talking about it. Every type of function that we deal with, we'll be doing polynomials, we'll be doing absolute value, we'll be doing piecewise, Lord have mercy, trig functions. All of these things are going to be described very, very heavily on increasing and decreasing, and a new one, because again, increasing and decreasing is something you did in Algebra 1 and Algebra 2, but concave up and concave down, okay? So intervals for increasing and decreasing, again, for those of you who were in my advanced algebra class last semester, we went over these a lot. We kept talking about them when we were doing polynomials all the time, about where the intervals were. So it's not really different as far as how it's written, right? The intervals are going to be done either in parentheses or brackets. The concave up and concave down, they're also intervals. Okay, so you're still talking about parentheses and brackets. So again, increasing and decreasing has not changed. Basically, if the input value is increasing and the output value is increasing, then the graph is increasing. And if the input value is increasing and the output is decreasing. So basically remember that input is your X and output is your Y, right? Domain and range. As your X's go up, your Y goes up. So it's like the end behavior on that one. And then the decreasing is as the X goes up, the Y goes down. So that's a decreasing. Okay, so concave up and concave down. There are two chances, right? 2 times that something is going to be concave up and 2 times that it's going to be concave down. So I need you to understand this is dealing with the slope or the rate of change of that function. Okay, and this is where people tend to get a little bit weird, so just follow with me. The rate of change is increasing, okay? And everybody's like, oh, it's going up. Okay, but you need to understand that if I were to take the rate of change here, and let's say maybe the rate of change from here to here is -2, and then I take the rate of change going from there to maybe here, and now the rate of change is -1, and then if I take the rate of change from there to there, it's going to be like maybe -0.5, okay? So when your rate of change is getting less negative, that is also increasing, right? Less negative means that the numbers are getting closer and closer to 0, and that means your total is actually increasing, right? So that's where people tend to get a little bit messed up on it. It's very easy to see it where it's increasing because I know if I go from here to here, it's going to be +0.5, and then here to here is going to be 1, and then there to there is going to be 2. It's getting bigger and bigger and bigger. But getting less negative is also an increase. Okay, and that's something that you need to understand. Same thing for rate of change is decreasing. Okay, so again, here to here, +2, here to here, +1, here to here, +0.5. We can visually see that rate of change, that slope is decreasing. Okay, because it's getting smaller and smaller and smaller. But the other side of concave down, the rate of change is decreasing. Okay, well, that would be -0.5, and then that would be -1, and that would be -2. So if it is getting more negative, that is also a decrease. Okay, and that's ones that tend to throw people. So I need to make sure you write this down. Give yourself some highlighted notes or some other examples that you can look at. The video notes are really good on this too. But that's the big thing that messes with people is that, again, there's 2 ways you can be concave up and 2 ways you can be concave down. Okay, so very, very important for the next several months we'll be dealing with concavity. Okay, so that's what I've already said. Basically, if the slope becomes less negative or the slope is approaching 0, that means it's concave up. And again, there's some good pictures that I've included with this, just so that you can actually see. And it's interesting in that. How do I put it? Okay, so for a fact that the graph itself, the y values or the dependent values are decreasing, but it's still concave up because the slope is increasing. Okay, and then you've got concave up and increasing. This is the one that's usually easy to recognize. Obviously, your y values are also increasing, and it's concave up because your rate of change is increasing. And that's usually, like I said, why it throws some people. So basically, I've broken it down into halves for you. And then the other one where you are concave down, your slope or your rate of change is decreasing. Okay, so your y values are decreasing. And again, you'll be asked, what intervals is this happening at the same time where it's concave down and decreasing or concave down and increasing, and you need to be able to split these apart. Okay, so it's concave down because the slope is getting more negative. Very good. and that means that your slope is basically decreasing, getting more negative. Okay, and then concave down and increasing. The y value is increasing. Obviously, the graph is going up. Why is it concave down? Because your rate of change is basically approaching zero, like where it gets flat, right? Your slope would be zero, so your rate of change is decreasing. So again, something that you're really, really going to need to work on, and we're going to practice on and make sure you get it, because this is a really, really big deal in pre-calculus and in calculus as well. Okay, so last part of the notes for this section, and then you can go on to the video notes if you have not already done them. So let's actually go ahead and break this down. So we have this graph, and we want to know where the graph is increasing, specifically what intervals. Okay, so when we're talking about this, increasing literally just means that the y value is going up, right? Okay, so it is increasing. This is decreasing, all right? This is aiming down. We're always going to go from left to right. That is something you also need to keep in mind whenever we do intervals. That's why we write them with the smallest number first, right? They're always supposed to go from left to right as if you were reading, okay? So this is decreasing. So the first place that this graph is increasing starts at -2, okay? And it stops increasing when it gets to 0, right? Because then the y values start going back down. Okay, and then where is it also increasing again? Well, it's increasing when we get to 4, because that's where it gets to a bottom, and then it stops because the graph stops at 7, and it stops at 7. So the two places where it is increasing is from -2 to 0 and 4 to 7. Again, for those of you who were in my Algebra 2 class last semester, we talked about how we write intervals with that little union symbol in between. I'm hoping if you had Browning or Whitmore for your advanced algebra class that you also did that. Whenever you're listing intervals and you have more than one that you have to list, like specifically like the domain and range on a rational function, where you had the asymptotes, you always put a union symbol to show that it's both of those pieces, or more than two if you have more than two. Okay, so decreasing. So being that the graph goes from -4 to 7, like that's the total domain, right? It has to be decreasing any of the places where it's not increasing, right? So that means it has to be decreasing from -4 to -2. And then again from 0 to 4. Because you only have those two choices. It's either going to be increasing or decreasing, unless we throw some flat lines in there, from some flat horizontals, which again, we'll get to when we start doing piecewise. Okay, so H is concave up. Now remember the definition. What does it mean to be concave up? I'll go back to it if you need to, just to make sure you've got it. Okay, concave up means that the slope is increasing, whether that means it's becoming more positive or less negative, okay? More positive, less negative. Okay, here the slope is constant, so we're not even going to look at that. That's basically a straight line. Okay, so what is happening here? We'll just go through it in sections. Is the slope becoming more positive, less positive, more negative, less negative? How would you put that as far as it being, you know, concave up, concave down? If you were to take the slope at individual pieces along this thing, this one is decreasing, right? Your slope is decreasing. It's going from being sharper to going towards 0. So that would be a decreasing, which means this is a concave down from here to here. Okay, so now check the next section from here to here, from 0 to 2. Okay, what is going on with this? The slope, again, if you were to take the slope here, it'd be 0, and then it would get more and more negative, right? It would get more and more negative as you go past. So that means that your slope is actually decreasing, becoming more negative. So that means it is concave down. All right, so let's check the next section from -2, or +2 rather, to 7, or even +2 to 4. Okay, so again, right now, the slope is negative. I know it's negative because it's going down, right, as we go from left to right. But is it becoming more or less negative as it goes from 2 to 4? Like here, your slope might be 1, or -1, and here your slope might be -0.5, and you get to here, and your slope is now 0. So your slope is increasing. Less negative, right, means it's increasing. So if it's increasing, that means it is concave up. All right, and let's try the last section from 4 to 7. What is going on with the rate of change there? Is it increasing, becoming more positive, or decreasing? If you take a look at it again, start off at 0. Maybe that's a half, maybe that's 1. You get up here and it's probably 2 or 3. So it is increasing. That means it is concave up. So this graph is concave up from 2 to 7. Okay, based on the definitions we talked about. And I know I'm going a little bit fast. I'm trying to keep the videos short. So if you need to rehear it, pause, rewind, do whatever you need to do. Okay, so now this is what I was talking about before about being able to tell the difference between increasing and decreasing with the concavity. Okay, so it needs to be increasing and concave down. Okay, so this is where this gets to be a little bit more, where you actually have to really look at whether it's concave down or concave up. Okay, and we've already split this up, makes it a little bit easier. It's increasing and concave down. Okay, so we already stated that it was concave down between -2 and 2, right? On which side is it increasing and concave down? Well, it's increasing, meaning that the y values are going up from -2 to 0. Okay? So, and then decreasing and concave up. So again, we've already figured out that it's concave up between 2 and 7, right? Where is it decreasing, meaning that the y value is getting less while it's concave up? And that is from 2 to 4. Okay. All right, so now we're going to be given the description, and then you have to draw the graph. Okay, so it's increasing. That just means that my y values are going up between -4, 1. I'll go ahead and put a point, and 5, 7. 5, 7's about here. Okay, so it's increasing. That just means the y values are going up, and is decreasing on the interval 1, 5. -4, 1, and 5, 7. Okay. And decreasing on the interval from 1, 5. Oh, on the interval from 1 to 5. Sorry. Okay, nope, my brain had a fart. Okay, I was thinking these are points and these are not points. Don't worry about me. We'll try this again. Okay, increasing on the intervals from -4 to 1. That means it's going up between these two x values, having a moment, and then going up again between 5 and 7. Again, having a moment was reading it as a point instead of an interval. And then decreasing on the interval from 1 to 5. So it has to go down here, and then up here, and up here. Okay, so it's just a visual. Okay, so it's going to go up and then come back down and then go back up. All right, so it's concave up on the interval from 3 to 6. Okay, 3 to 6. It's concave up. Okay, that means that the slope is getting more positive or less negative. So that means it curves. More than likely something like that. Okay, and concave down on the intervals from -4 to +3. So you're going to have some kind of curve from -4 to 3 that looks like this, and from 6 to 7. So that means it actually stops at 6 and then goes back down, or starts to go back down like that. So there's a lot of different ways, again, that you can draw this. But again, it's getting that visual, right? So I know it is going up from -4 to 1, okay, to +1, which is about basically where it would kind of top out at the top of the curve. So let's actually make that a little bit more specific. Okay. And then it's going to curve back down because of the concavity, right? And then it's going to be going up again, concave up. Ooh, that's a little bit messy. Okay. Concave up from 6 to 7, meaning that it's, concave down means that my slope is decreasing. So it's basically going towards 0 again. And then from -4 to 3, concave down again means my slope is decreasing. So yeah, kind of a messy picture, but again, the idea as far as being able to differentiate between concave up and decreasing, concave down and decrease, going to be able to go all 4 of the different things. And your picture could be a little bit different than this, and it would be fine. Again, it's just the idea of where these pieces are. Okay, so again, the video notes that go with AP Classroom are really good as well. I've included those in your Canvas course, and I will see you tomorrow.